Students, we were discussing the synthesis of polypeptides in the last class. Continuing on the same topic, today we will be discussing the second and the last method for the synthesis of polypeptides, that is Merrifield method or solid phase method. In this method, the amino acid or a peptide is first chemically bound to an insoluble polymer having a structure like this. So after binding the amino acid to a polymer, the chain is built one by one from the free end. So this is usually the polymer. This is the structure of polymer used. For simplicity, you can write it like polymer CH2Cl. So, in the first step, a basic solution of amino acid in ethyl acetate is shaken with the insoluble polymer. So, in basic solution, the amino acid exists as a carboxylate ion. The carboxylate ion react with the polymer in an SN2 manner to form the polymer bound amino acid. The O- will attack the CH2, Cl- will leave, and we will get polymer CH2O, C double bond O, CHR, NH2. So, our amino acid, one of our amino acid has been bound to the insoluble polymer in an SN2 reaction. The next step, take another amino acid and protect the amino group of the second amino acid using tertiary butoxy acidoformate. Tertiary butyl OCON3. This is known as tertiary butoxy acidoformate. Tertiary butoxy acidoformate. Here, the acid group N3 will react with one of the hydrogen to eliminate hydroxoic acid minus HN3, and then we will get COOH, CH, R dash, NHCO or tertiary butyl. This is the N-protected amino acid, N-protected second amino acid. In the next step, the N-protected amino acid is reacted with the polymer bound first amino acid in the presence of a condensation agent. Used here is dicyclohexyl carbodiamide, DCC. Dicyclohexyl carbodiamide, DCC. Then this COOH will react with the free NH2 of the first amino acid molecule to remove a molecule of water to form the first peptide bond. In the next step, so this type of peptide bond construction is continued, and the tertiary butoxide protection of the amino group have to be removed. So that is removed so that we will get a free NH2 group. That is removed using TFA, trifluoroacetic acid. It removes this part, tertiary butoxy formyl part, and NH2 is freed. So we will get a polymer bound dipeptide. Now, the polymer bound dipeptide is treated with another N-protected amino acid in the presence of DCC, followed by the deprotection of NH2 group will give a tripeptide. This process is continued to get a polypeptide. Now, after obtaining the desired polypeptide, we have to remove the polymer from the peptide part. So that is done by treating the polymer bound peptide with the hydrogen fluoride, anhydrous hydrogen fluoride. When this polymer CH2 part leaves, or this can be separated, and this polymer CH2 will be replaced by H. We will get polymer separated peptide. So this is the entire step of the Merrifield synthesis. Now, Merrifield synthesis is advantageous over all other method of synthesis of peptide, in that it gives better yield of peptides and proteins. Time consumed is less. Due to the formation of the solid insoluble polymer, there is no need of a purification technique. The insoluble polymer can be separated simply by filtration. So I hope Merrifield synthesis is clear. Again, if you have any doubt, please contact me personally. Thank you.